Have you ever dropped your phone and watched in horror as a spiderweb of cracks spreads across the screen? What if I told you that in the near future, that shattered screen could just fix itself? It sounds like science fiction, but it's the very real and incredible world of self-healing materials. This isn't just about phones. We're talking about a technology that could revolutionize everything from our clothes to the roads we drive on. Today, we're diving deep into the materials that can literally put themselves back together. So, what exactly are self-healing materials? At their core, they're smart materials designed to automatically repair damage without any human intervention. The inspiration for this is all around us, in nature. Think about it. When you get a small cut, your skin doesn't just stay broken. Your body kicks into gear, clots the blood, and slowly rebuilds the tissue until the wound is gone. Scientists looked at this amazing biological process and thought, can we make our stuff do that? The answer, it turns out, is a resounding yes. They are creating polymers, metals, and composites that can mend cracks, scratches, and even significant fractures, extending the lifespan and improving the safety of countless products. One of the most fascinating methods for self-healing is the microcapsule approach. Imagine a material filled with millions of tiny microscopic spheres, almost like tiny eggs. Each of these microcapsules is filled with a liquid healing agent. The material itself also has a catalyst, a chemical trigger, mixed into its structure. Now, when a crack forms, it's like a tiny earthquake tearing through the material. As the crack spreads, it ruptures these microcapsules, releasing the healing agent. This liquid then flows into the crack, just like you'd apply glue. When it comes into contact with the catalyst that's already in the material, a chemical reaction starts. This reaction causes the liquid to harden or polymerize, effectively gluing the crack shut from the inside out and restoring the material's strength. It's a beautifully simple yet brilliant system, a built-in automatic repair crew waiting for the moment it's needed. But that's just one way to do it. Another major approach relies on something called reversible chemical bonds. This is a bit more like having a reset button at a molecular level. These materials are built with special chemical links that can be broken and then reformed. Think of it like tiny magnets holding everything together. When the material is damaged, these magnetic links are pulled apart, but they haven't lost their attraction. By applying a specific trigger, like a bit of heat or a flash of ultraviolet light, you can give these bonds the energy they need to snap back together. The molecules realign themselves, pulling the edges of the crack together and reforming the chemical links, making the material whole again. What's incredible about this method is that in many cases, it can be repeated over and over. You could theoretically heal the same spot multiple times, making the material almost immortal. The potential applications for this technology are mind-blowing and stretch far beyond just our phone screens, though that's a great place to start. Imagine car paint that heals its own scratches after a day in the sun, or airplane wings that can detect and repair microscopic fatigue cracks in mid-flight, dramatically increasing safety. Think about infrastructure. We could have self-healing concrete that seals its own cracks when it rains, preventing water from seeping in and causing further decay. This could save us billions in road and bridge maintenance. What about clothing? A tear in your favorite jacket could mend itself with a little heat. Or medical implants that can repair wear and tear inside the body, reducing the need for risky replacement surgeries. Even spacecraft could benefit, repairing micrometeoroid impacts while millions of miles from Earth. The possibilities are truly transformative, touching almost every aspect of our modern world. As we've touched on, the ultimate inspiration for all this innovation is nature itself. It's a field called biomimicry, learning from nature's genius to solve human problems. For millions of years, biological organisms have perfected the art of healing. Skin is the classic example, but it's everywhere. Trees can seal wounds in their bark with resin to prevent infection. Some lizards can regrow their entire tails after losing them. Starfish can regenerate entire limbs. By studying the chemical process and structural designs that make these feats possible, scientists are uncovering blueprints for our own materials. They're learning how to create complex vascular networks, like our own blood vessels, within materials to deliver healing agents more effectively. It's a testament to the idea that sometimes the most futuristic solutions have been hiding in plain sight in the natural world all along. Of course, we're not quite living in a world of self-healing everything just yet. There are some significant hurdles to overcome. The first is cost. Creating these complex materials is currently much more expensive than producing their conventional counterparts. We need to find ways to scale up production to make them economically viable for everyday products. Then there's the durability of the heel. While many materials can regain a high percentage of their original strength, it's often not a perfect 100%. And for reversible systems, how many times can a material really heal before it starts to degrade? We also need to ensure these materials are stable and don't just randomly start healing when they're not supposed to. But despite these challenges, the pace of research is incredibly fast. What was a lab curiosity a decade ago is now moving into real-world testing. So, what does the future hold? Researchers are pushing the boundaries every single day. They're reworking with advanced smart polymers that can react to a wider range of stimuli and heal more efficiently. They're incorporating nanomaterials like carbon nanotubes and graphene to create materials that are not only self-healing, but also stronger and lighter than anything we have today. A major goal is creating materials that can heal multiple times in the same spot without any loss of performance. Some are even developing systems that don't just heal but also feel materials with built-in sensors that can report damage, its location, and its severity before initiating the repair process. This will create truly intelligent, autonomous structures that look after themselves. The ultimate vision is a circular economy of materials where things last longer, require fewer repairs, and create less waste. From phone screens that mend themselves to bridges that defy age and wear, self-healing materials are poised to change the way we think about the objects we create and use. It's a shift from a disposable mindset to one of resilience and longevity. This technology promises not just more convenient products, but a safer, more sustainable, and more efficient world. The road ahead is long, but the foundation is being laid for a future where the things we build can take care of themselves. Thank you so much for joining me on this look into the future of materials science. What self-healing application are you most excited about? Let me know down in the comments. And if you enjoyed this video and want to keep exploring the amazing technology shaping our future, be sure to hit that subscribe button and turn on notifications so you don't miss our next video. Thanks for watching, and I'll see you in the next one.